Let's now try to understand the syntax, so let's do some anatomy of the typecast, okay? Let's now see exactly what's going to happen when we do a typecast. It's really important to understand every single detail. Otherwise, you will just get confused when we try to apply the typecasting in other contexts. Okay, let's see this. So far, we got Jim. Statically will be students over here. And also dynamically, it's pointing to some resident students objects over here. And there will be some attribute for premium rates. And let's just omit the value over here. It's not important. This is what we write over here. And let me just want to highlight over here, this line over here. So this will be so-called the cast type. That's what I will refer to. Okay, let me now write it down. It's called the cast type. The type that we want to cast. Later on, we'll talk about two different issues for typecasting, whether or not it will compile, and also whether or not it will run into some runtime class cast exception, but that will be for later. I just want to look ahead a little bit. Let's now first understand the syntax, okay? You can see Jim is over here, right? Jim has the static type students over here, right? So what does it really mean when we want to say we want to cast Jim to resident students, okay? Let's just assume this is going to be valid to do the cast. We'll talk about under what circumstances can a cast actually be valid. But for now, let's assume it will be valid. Would you want to see the different parts for a cast? Okay, so this part over here, as I said over here, is going to create some alias whose static type is actually resident students. So we are not creating any new objects. It's so important for you to realize. Whenever we are doing typecasting, we are not creating any new objects. All we are doing is we are creating some alias for the objects with a different static type. But for the original reference over here, so we are saying that we are casting Jim, but Jim's static type never changes, as we said before. Okay, so what we're doing here is, so for this particular part, it's going to be for this part here. For this part here, as I said, it's going to be some alias, and the alias is simply going to be a link, like a pointer. It's going to be some alias over here. Okay, this part over here is going to point to wherever Jim is pointing to, and then this particular alias has the static type resident students, which will simply correspond to the cast type. So this will be resident students, and static type. And then you can let me just put down here. So that's the resident students, and then Jim. So notice that this is the syntax that I just explained over here. So this part over here. So this part over here is simply just a link, an alias to the same objects, but its static type is simply corresponding to the cast type over here, right? That's about the right hand side. And the Jim static type never changes. And we are trying to do some variable substitution, and the entire expression over here is simply referring to this alias, this link over here, the cast. And what's its static type? It's simply just resident students. So that is why I said resident student here. Now, can resident students substitute for RS, which is statically declared as resident students? The answer is yes, because resident student here can fulfill all the expectation of resident student here, because resident students is a descendant clause of itself. So that's okay, right? So that's why I said over here it is a valid substitution. But let me complete the picture over here. How do we visualize, let's say, this part over here? RS is just another reference variable, which I'll put over here, and then its static type is resident students over here. So it's going to be resident students over here. It's a static type. So it will simply just point to wherever the link, the alias is pointing to, the cast link is pointing to, and it is going to point to this particular object over here. So now what we got is, we got the original Jim, statically students, pointing to these objects. We also got RS, which we just get reassigned, is also pointing to the same objects over here. And its static type is actually different. It's actually resident students, which has more expectation. Okay, so now if you look at and the way we can create RS is by creating this intermediate cast link over here. So that's important. And you can also choose to use this expression over here. It's called anonymous cast. We can do that as well, but we'll see that a little bit later. Okay, let's see what the consequence is. It's very important. When we talk about expectation over here, so now we got three different expressions over here. So we got Jim, the original one, and also we got the cast version, which is resident, students, and Jim. By the way, this is actually already valid. It's called anonymous cast, a cast without a name. Okay, so this is one expression over here, and this, let me use a different color. Okay, so this is one expression. This is just another expression, and another one I want to write is the RS. RS is simply the third expression. Now we want to talk about their expectation. What can we say? What are the expectation? For example, what can I say? Jim dot. What can I say? Resident students Jim and then dot. And just a little bit more information. If you want to really use a dot notation for anonymous cast, which I will talk about, you must actually put another round brackets over here. Otherwise, you will be interpreted the wrong way. Okay, just to remind you. And also, what can we say? RS dot and something. So Jim dot is going to be residents. Jim static type will be students. So we can say things like, if you recall the hierarchy, right? It's going to be names, name, courses, number of courses, and also register, and also get tuition. Okay, in fact, this will be the common expectation for all the three. Okay, it's actually very important. So what I will do is I'm gonna move that to the middle. So it's gonna be for all the three expressions. That's number one. Okay, I'm just gonna do this. So for all the three expectation, you can definitely say Jim.name, Jim.courses, Jim.noc. Also, you can say this particular anonymous cast dot name dot courses dot noc, and also you can say rs.name, rs.courses, rs.noc, and etc. Right? But what's more to it is, for this anonymous cast over here, the cast type is simply resident students. In that case, its static type is at the same time also resident students. So what can we get more from this particular expression? We can get premium rates and also set premium rates. I'll just say set PR. You will know what I mean. And also, what about RS? RS statically is declared to be resident students, so we can also say premium RS premium rates. We can also say RS set premium rate as well. All right, so that's about the anatomy of the typecast. Let me recap. We are not creating any new objects. Jim originally, Jim declared to be static type students never changes its static type. It's always pointing to this object over here. And we are creating two aliases basically. One is on the right hand side over here. It's a so-called anonymous cast over here. So RS, Jim is cast to RS, resident students, pointing to the same objects. And also RS over here, and to really judge to see whether or not the substitution is really valid, we only gotta judge to see the entire expression over here has the static type corresponding to the cast type, which is resident students. So resident students can fulfill resident student. That's why it's valid. So we are also at the same time creating a second alias, which is RS, pointing to the same objects. So there are three links that are involved in the typecast. You got to be very clear about what the three links are. And then we talk about the expectation for each one of them, right? For Jim, is only going to be limited to just by its static type, which is students. For the anonymous cast, whose static type will just be resident students, corresponding to the cast type. And for RS over here, it's declared to be resident students. So that's why for both of them, you also got the expectation for premium rates and also set premium rates. All right, hopefully that's clear. Let me go back. And you can definitely go through the slides. Everything has been set already. But I think you want to combine both the slides and my visualization, the notes. Okay, and that's the anatomy of the typecast, which I also went over. I'll let you maybe study the slides as well, right? Nothing has been skipped. Okay, and so that's about motivating example number 1. I got another motivating example for you, but this time I'm using the smartphone type hierarchy over here. And for this one, it's going to be exactly the same reasoning pattern about why you will be undecidable for the compiler to infer the dynamic type, in this case for a phone over here. And also we talk about how we can really force the compiler to believe it by using a typecast. So that's something I will let you study for this second motivating example. You'll be very similar to the first one, so we don't need to waste the time in the video. Okay, but I'll let you study that if you find the need. But I would highly recommend you do so. All right, so that's something I'm gonna skip just for now because I've already talked about it. And always remember this diagram over here about what I meant by 3 links are actually involved in a particular typecast. It's so important for you to know. Okay. And let's now talk about typecast, a little bit more about syntax, which I already said, about named versus anonymous. Okay, anonymous simply means without a name. Okay, let me just switch directly to iPad. Okay, let me talk about it very quickly. Okay, so what I'm doing here is, you can see here, in the case of name cast, okay, we got name cast versus anonymous cast over here. And I'm just using motivating example number 2. So if you have already gone over yourself, that'll be more familiar to you. But otherwise, you can just refer to the slides over here. So here we're doing some cast over here. So why do I say it's a name cast? This part over here, only this part, is the anonymous cast. Okay, let me just say, just this part over here is anonymous cast. Anonymous cast. However, we are assigning this particular alias to another alias for Hyang over here. So that's why, after all, we actually got something that we can refer to, which will be for Hyang over here. That's why I say it's the name cast. On the other hand, what we can do is we can simply do this. We can say this is the cast over here, a phone. We are casting a phone into iPhone 13 Pro. And then notice that we are using the surrounding parentheses over here before we apply the dot notation. So that's also fine. So this part over here is really the anonymous cast again. Anonymous, okay, cast. Okay, it's important for you to see. So these are the 2 different syntax. And I'll give you more example for each one of them, especially about how to use the anonymous cast to do some interesting application. So a very quick tip for you: when should you use anonymous cast? And I will draw you some analogy about when to use anonymous objects. When should you use objects without a name? When you actually don't want to give it a name. So similarly, if you simply just want to, you have some variable phone whose static type is too restrictive. In that case, you may just want to cast a phone into something that will give you more expectation, but you don't want to give us a variable name, like in this case, like for Hyang. Maybe you don't want to do it, you simply want to write down the cast and then apply the method you want to call right away. Okay, that's maybe some scenario you want to get into. You will see more example. Let's now do some exercise over here. Can you please take a look at this expression over here? So we got a phone, okay, so smartphone and also iPhone 13 Pro. Very quickly, is this variable assignment here valid? Static type is smartphone over here. And also, we got dynamic type is iPhone 13 Pro, which is over here. So now the question to ask about substitution is, can we substitute iPhone 13 Pro for smartphone? The answer is yes, we can, because iPhone 13 Pro is a descending class of smartphone, meaning that iPhone 13 Pro can fulfill all the expectation that's imposed upon smartphone, which will be dial and surf web. Right? It's something you should be very familiar with already. And over here, can we write such expression over here? Okay, pause the video and think about it. All right, assuming that you thought about it, the answer is no, you cannot. Because you got to think about how this will be interpreted by the compiler. this particular line over here is going to be interpreted as I want to invoke a phone.FaceTime and then do the cast. It's going to be interpreted this call first. And then I want to cast whatever the return value might be from FaceTime and cast later. This is how the order of evaluation is gonna happen at the runtime, right? So now in this case, should this be allowed? Well, let's look at this expression here. A phone statically is simply smartphone. So after the dot over here, it will only be allowed if it's part of the expectation for a phone static type. Is FaceTime part of the expectation of smartphone? No. Is FaceTime the expectations of a phone's static type, which is smartphone? It is not, because for smartphone you only got expectation for dial and surf web. You don't have the FaceTime. The FaceTime will only be applicable to, for example, iPhone 13 Pro, right? So this is not going to work. So maybe what you meant to do is like this. You want to say a phone, you want to do cast first. A phone, and then you want to cast that into iPhone 13 Pro. 13. Let me move that away a little bit. iPhone 13 Pro. So this will be the cast. And then we want to do the method call later. After this, we can say over here and bracket that like that, and then we'll say dot FaceTime. So this will be okay, because after doing the cast, you can see this part over here. What will be the static type for this expression? That's something we explain in the anatomy of the cast, right? You can see when we try to say resident students casting Jim, the static type for the alias would just be resident student. Similarly, you can see here, if we were trying to cast a phone into iPhone 13 Pro, assuming that the cast is actually valid. So this will have the static type iPhone 13 Pro. And now, is FaceTime part of the expectation for iPhone 13 Pro? Indeed, it is, because you can see iPhone 13 Pro is going to inherit all the expectation from its ancestor path. So you can see from its parents, you got FaceTime from iOS. So that's actually okay. All right. So this is actually okay. On the other hand, this expression over here would not be okay. It's not going to compile because you didn't really force the evaluation order to be cast first and then call first. Okay, so that's about the named versus anonymous cast. Hopefully that makes sense. Let's now go back to the slides, and everything has been said already. And let's now move on to the next topic about some notes about the cast.